Hey guys, welcome back to General Chemistry. It was requested that I do another stoichiometry problem, but this time I link the train tracks together as one big long problem. So this is something that if you're taking my course, Active Chemistry does ask of you in the homework, so hopefully this will help you with that problem. It's also something that is a more efficient way to solve these problems. So as you get proficient at the train tracks, if you can start linking them together as one big long problem, it's going to save you some time and it's going to save you some keystrokes on the calculator. So certainly a skill that will apply to anyone that's watching this video. So the problem that I'm going to solve is the following problem. I'm going to move through this problem fairly quickly. My assumption is if you're watching this, you've practiced some of these, you're starting to get a good feel for them, and this is just a new skill that you're adding on. So one of the components of acid rain is when NO2, a pollutant, reacts with oxygen and rainwater to form nitric acid. So assuming there is more than enough oxygen and water, how many grams of nitric acid, HNO3, forms from 1.5 grams of NO2, the pollutant? Okay. So before I dive into this, I want to just kind of have a map of the problem, like where am I going, what am I doing? So we're going to start with the information that's given. So we're going to start with 1.5 grams of NO2. And then we're going to take that to moles of NO2. Then I need to just peek back at the problem. Where is it? What's my destination? So it wants to know about the nitric acid. So I'm going to take moles of NO2 to moles of HNO3. And then lastly, it's asking for grams. So we're going to take that to grams of HNO3. Okay. So that's just kind of our thoughtful path through this problem. So I'm going to write that again up here. 1.5 grams NO2 moles NO2 moles HNO3 and then grams HNO3. Okay. All right, so I'm going to do this train track as like one continuous train track. I'm going to try to do it small enough so I can fit it on this slide. So we always start with information that's given. So 1.5 grams of NO2. And we draw our train track, grams of NO2 on the bottom, moles of NO2 on the top. Okay, so this is just going this grams to moles. Grams of NO2 cancels, so that's gone. We'll be left with moles of NO2. And then we use the molar mass here. So 1 mole of NO2, and let me just real quick, 15.999 times 2 plus 14.007, and this is 46.0. Okay. All right, so we want to continue our train track on. I'm not actually going to plug anything into the calculator until the very end. So here we are in moles of NO2. So that's the starting unit. So I'm going to put moles of NO2 down here on the bottom of my train track because that's what's getting canceled. And then my destination for this step were moles of NO2 to moles of that nitric acid. So that's going to go on the top. Okay. So just to kind of revisit that, our starting place is now here. Like this is canceled. We're ignoring that. So we're in moles of NO2. So that's going to go diagonal. And my destination for this step is moles of HNO3. So that's going to go on the top. Okay. And this is our mole to mole ratio. So we have to look at the balanced chemical equation. I see the number 4 is attached to NO2. And I see the number 4 is attached to the HNO3. So those coefficients are going to stick with their molecules. So there's a 4 in front of this guy, and there is a 4 in front of this guy. All right, and now I'm just going to continue my train track on. Okay. Now we look, so moles of NO2 cancel, moles of NO2 cancel, that unit is gone. Now we are in moles of HNO3, so that becomes our starting point. So moles of HNO3 on top. We're going to put moles of HNO3 on the bottom. Okay, so that's the unit we're trying to get rid of, so that goes diagonal. We are here. Our destination needs to go on the top line, so our final destination is grams of HNO3. Okay. All right, and then to fill in the pieces here, we're going to use the molar mass again. So 1 mole of the HNO3, and let me just quickly calculate that, 15.999 times 3 plus 14.007 plus 1.008. So the molar mass of HNO3 is 63.01. Okay. Now that I have all of my numbers in place, man, you could solve this in any number of ways. Let me get my pointer here. You could multiply all of the numbers on top and then divide by any of the numbers on the bottom. You could bounce back and forth, so 1.5 divided by 46 times 4 divided by 4 times 63 divided by 1. So really anything that fits in that PEMDAS algebraic step category, you can solve it that way. I tend to multiply across the top and divide by the bottom, but I'm not saying that's the right way to do it. There's other ways. So I'm going to take 1.5 times 4, so I'm going across here, times 63.01. And then I'm going to come back and divide by anything on the bottom. So that I'm going to take that answer and divide it by 46.0. And I hit equals, divided by 4, equals, divided by 1. And the answer that spits out is 2.05. And then we just got to find our units. So the only unit that's left standing is grams of HNO3. So that's the answer that I would report. Okay. So this is what active is looking for. It's looking for you to line up the units and then just simply put the numbers in. And then you do one calculation at the very end, and that's the answer that you would report. I hope you guys found this helpful.